This is Professor Gavoor. Let's talk about Chapter 8 and moving into the next major phase of this class, which is studying the different types of models of the firm. And the first one we're going to look at is perfect competition. We'll cover what it is and why it matters, and how perfectly competitive firms make their decisions on how much to run. And we'll do some entry and exit decisions in the long run and efficiency in perfectly competitive markets. So mostly what we're talking about here is commodities, like wheat. Depending on the competition and prices offered, a wheat farmer may choose to grow a different crop. There's lots of wheat farmers, there's lots of wheat grown, and people either make money at it or not, and if they think they can make money at planting a different crop, they may well do so. And we're going to discuss what motivates those kinds of decisions. So the first thing we're going to talk about is like market structure. The conditions in an industry, number of sellers, how difficult it is for a new firm to enter, and the kind of products that are sold. When we talk about perfect competition, and we've talked about market structure before, we have perfect competition, which we're going to cover now, monopoly, which we will cover next, and then monopolistic competition and oligopoly, which we'll cover both at the same time, the kind of the middle road. So perfect competition, each firm has many competitors that sell almost identical products. The example we used was wheat. Apple growers. So that's why agriculture is often where perfect competition is mostly applied. And there's 4 criteria. Many firms produce identical products. Many buyers and many sellers are available. Sellers and buyers have all the relevant information to make rational decisions. And firms can enter and leave the market without very many restrictions. If I want to become a farmer, I could grow wheat in my backyard if I want it. All I have to do is buy the wheat seed and have the shovels and other implements I might need to tear up my lawn and put in wheat. Don't count on me doing that unless this crisis gets way worse. And in this one, the people that produce, the firms that produce the farmers are price takers. That means a firm in this kind of market, a perfectly competitive market, must take the prevailing market prices given. I don't have any choice. If you ever grew up and were up early enough in rural areas, I remember as a kid when I used to listen to the radio early in the morning, and I would hear the farm report, and they would talk about the price per bushel for corn or wheat or different other agricultural products. And farmers pay a lot of attention to that because their costs they have a fixed cost for their farm and equipment that they have. And then they have the variable cost of the seed and the labor and the fertilizer and all of that. And if it's like a wonderful summer and everybody's growing all of the product that they can, let's say wheat, we'll stick with wheat here, and it's a bumper crop for wheat, there'll be a bountiful amount and the price per bushel will go down. If it's a struggling year where maybe there's a drought, maybe it was a late spring, lots of rain, too much rain perhaps, and not ideal conditions for growing the particular crop, then farmers may have to the supply and demand will flip-flop, and the farmers may have a little bit of an edge and get higher prices. But they cannot set the price. If I'm selling wheat and the market price is $5 a bushel, for example, I can't sell it for $6 and claim my wheat is that much better. Sorry, I get phone calls sometimes. So they're price takers. Here's the things to remember. 5 criteria, actually. Many firms producing identical products. many buyers, many sellers in the marketplace. Everybody has all the relevant information. Firms can enter and leave the market without very many restrictions, and the firms are price takers. So, perfectly competitive firm has only one major decision to make: what quantity to produce. How much are we going to produce? A perfectly competitive firm must accept a price, they're price takers, for its output as determined by the market. If there's only one producer in the market, for example, in a monopoly, they can set the price. So they're a price maker. The extreme opposite of that is perfect competition, where the market sets the price. A maximum profit will occur at a quantity where the difference between a total revenue and a total cost is largest. So immediately, we draw a lot of graphs here. So let's talk about this perfectly competitive market of raspberries. And you'll see that we have a total revenue line, a straight line. The more you grow, the more you sell. We have a total cost line, which seems to go at one slope to a certain point and then increases thereafter. And if we look at where that gap is the largest, which makes it sound like it's here, not here, we have a profit of 75 and we have a profit of 75. So the total revenue for a perfectly competitive firm is a straight line sloping up. The more you, because the price is fixed. We're looking at a specific point in time where the market price is fixed. Total cost also slopes up, but probably with some curvature, as they say. You know, you have kind of one curve to a certain point, and then costs increase. Maybe to get more yield out of your fields, or you have to increase the fertilizer so much it costs you more, or to get more yield, you have to, or to develop more crops, you have to rent more land to plant the crop in. So I think the costs can go up. Obviously, you don't want to produce this low volume because cost is higher than revenue. You want to be in this region where revenue is higher than cost, and you don't want to be here where, again, cost is higher than revenue. So at higher levels, and we're going to talk about this, marginal returns and marginal profit and marginal costs and all of that. The total cost also slopes up, as we said. At higher levels of output, total cost begins to slope upward more steeply because of diminishing marginal returns. It costs you more money, more cost to get the next level of production, to get the next unit of production. And again, we said maximum profit occurs where there's the greatest difference between total revenue and total cost. So here's the two concepts again. Marginal revenue, change in total revenue divided by change in quantity. And marginal cost, the cost per additional unit sold. And it's change in total cost divided by change in quantity. Another way of looking at marginal revenue, it's the additional revenue gained from selling one more unit, and the additional marginal cost is the additional cost incurred from selling one more unit or producing one more unit. So the profit maximizing choice for a perfectly competitive firm is where marginal revenue equals marginal cost. Now this is basically the magic of calculus, and if you haven't had any calculus, I have profit is a revenue curve, your revenue function minus your cost function, and I take the first derivative, so it's the first derivative of the revenue function minus the first derivative of the cost function, and we know that we achieve optima, either maxima or minima, when the first derivative is equal to 0. Another word for first derivative of revenue is marginal revenue. Another word for first derivative of cost is marginal cost. So it's when marginal revenue minus marginal cost equals 0, or therefore where the quantity where marginal revenue equals marginal cost. And there's some magic in that. So if we look at the marginal revenue, marginal cost at the raspberry farm, you have total packs of raspberries, and we have a supply, we have demand. We see that we're going to produce 80 of them at $4. So the equilibrium price for raspberries is determined through the interaction of market supply and demand. And maybe this 80 is 80 million packs of raspberries, or 80,000 packs, or whatever, however they're going to measure this. And here's the marginal cost slash marginal revenue. Now, your marginal cost curves and marginal tend to look like this. Your marginal cost curve tends to, in a perfectly competitive firm, tends to look like a U. It starts off a little high, and then your costs get lower and lower and lower, and you have a minimum marginal cost. And then it starts to increase for the reasons we talked about before. You need more fertilizer, you need more labor, you got to rent more land, and so your marginal costs get steep here. The marginal revenue curve is always horizontal line, and is basically called the price. It's at the price, because remember that we said that the supply curve, the revenue curve, was a straight line. So the revenue curve is price times quantity, basically. And so the first derivative of a line is the slope. The slope is the marginal revenue. The slope is the price. Price, therefore, is marginal revenue. So the marginal cost curve is somewhat initially downward sloping. If there's a region of increasing marginal returns at the low ends of output, it eventually starts sloping upward when diminishing marginal returns kicks in. Does maximizing profit, producing where marginal revenue equals marginal cost, imply an actual economic profit? Not necessarily. It just says it could be your minimum loss could be your maximum profit. So the answer depends on the relationship between price and average total cost, which is the average profit or profit margin. So now we're going to start looking at a couple curves here all simultaneously. A, we have the average cost and we have the marginal cost. Remember that the marginal cost will intersect the average cost curve at the minimum of the average cost curve. That's the case everywhere. We're going to see that we have an average cost curve here. We have a marginal cost. It's kind of got almost a U-ish shape. And the marginal cost curve intersects the average cost curve at the lowest point. Then we have a marginal revenue curve. A marginal revenue curve, which is actually the price. And we want to operate where marginal revenue equals marginal cost. So I want to produce 90 packs of raspberries here. And if I go to my average cost minus my price, that's the margin. Much like we did in the first week. So quantity, which is along the x-axis, times this marginal profit, which is price minus average cost at that production level. I get this rectangle. Quantity times margin equals profit. It's blue here, which means that it's going to be profitable. The price is above the average cost. When the price equals the average cost, in this number B, we see that the marginal cost and the price intersect at the minimum average cost. That's really the only point where these two can equal the average cost, where price equals cost. Now there's no margin, and you're going to make zero. You're going to make zero economic profit, but you're going to sell 70 of them, and you're going to be here. So in A, the price intersects marginal cost above the average cost curve. Since price is above average cost, like we talked about, if price is above variable cost, in a sense, the firm is making a profit. Remember from week 1 when we did your crazy uncle problem. And B, the price intersects marginal cost at the minimum point of the average cost curve. Since price equals average cost, the firm is breaking even. No economic profit. Or something they call normal profit, which is kind of a little bit confusing, but there is that's what they call normal profit in a perfectly competitive environment. In C, we see that the price is lower. So the price, when it hits that marginal cost curve, it's below the average cost curve. So now your average cost or your variable cost is above the price. So this is negative, hence this part is red, and you multiply that times the quantity, you still get a profit, but it happens to be a negative profit, so it's a loss. Since price is below average cost, the firm is making a loss. You really need to study this, okay? And there's another chart in here you really need to study. Okay, so a discussion question. Can a firm not avoid losses by shutting down and not producing at all? Well, here's an excellent question. Sometimes it's cheaper to produce than to shut down. If the price is below the minimum average variable cost, the firm should shut down. If the price is above the average variable cost, then the firm stays in business. You might not be making money, but at least if the price is above the average variable cost, everything that you make will be contributing. You're just not contributing enough volume to break even or be in a positive profit. Let's look at this picture. So again, we're looking at these crazy graphs. Average cost, marginal cost, and then you have average variable cost. So the average cost is the average total cost. It's got the fixed cost in there. The average variable cost is the margin. It's like our variable cost, like we did at first, is not the margin. So the price is below the average variable cost. Here's my average variable cost. My price is below there. Or my price is above the average variable cost. So it means I'm having a positive margin in here. Sorry, excuse me, I got confused. Let's just read this. In A, the farm produces at a level of 65. It is making a loss, but as the price is above the average variable cost, it continues to operate. Why would you continue to operate if you're making a loss? Because what is your loss? Your loss, if you don't produce at all, your loss is a fixed cost. Right? You still have to pay your fixed costs. So shutting down, you have to pay your fixed costs. If I'm able to sell product at a price higher than my margin, my variable costs, excuse me, I keep making the same mistake. If I'm able to sell my product at a price that's higher than the average variable cost, so if price is greater than variable cost, I have some chance of making money. Everything I produce, I'm selling at a slight profit. Not enough to cover my fixed cost, but it's chipping away at it for each extra unit I produce. Eventually, it could reach break-even point. Eventually, it could break into the positive, profitable area. So when I would lose less money in this scenario by actually producing. Whatever I produce will diminish my loss. It'll chip away at the fixed cost, which would be the loss if I didn't produce at all. Now, in the next picture, if the price is below the average variable cost, if the price is below, everything I produce, I will lose even more. So my losses mount for each extra item I produce, no matter in what volume. so that it makes sense to just shut down, because the minimal cost, therefore, would be just the fixed cost. My minimum profit would be the negative profit, which would be the total fixed cost. In the first case, every item I produce will produce a marginal profit because the price is higher than the minimum average variable cost, and it will subtract from the fixed cost. You got to pay attention to this. The farm produces at a level of 60. This price is below the average variable cost for this level of output. If the farmer cannot pay workers the variable cost, then it has to shut down. So it's just a matter of where this price is, where you fit the price. There's three regions. There's this point here, minimum average variable cost. When the price is lower than that, you shut down. The best you can do is just to take the loss, which is your fixed cost. Then you have this region in between the minimum average variable cost and the minimum average total cost. This is a break-even point. In here, it makes sense to produce because your losses will be less than the fixed cost. Where you want to operate is in region 3, where if the price is above the minimum average cost, then I will be in a positive profit. Study this graph and study these graphs. That's the key to understanding this. And if you need help, call me. If you need help, watch other videos. That AC/DC economics is probably a good place. I try to be high energy, but no way I can ever match him. So here's another picture of it. Here's the 3 zones. The shutdown zone, which I like to call zone 1. Here's the minimum, here's the average variable cost, here's the average cost. It's always going to be higher. The difference between these two curves is going to be average fixed cost. The two curves get closer and closer together. If you produce at 0, the difference is exactly the fixed cost. And as you increase, your average fixed cost goes down because I'm dividing by a larger cube. So these two curves kind of converge but never do. So I have 3. Here's my break-even point. Here's my shutdown point. You have my price, which is a horizontal line always, which is also my marginal revenue, is below here, shut down. If it's in between here, unfortunately, you have to produce because you'll lose less money because your price is greater than the average variable cost but below the minimum average cost. But when your price is above the minimum average cost, you'll be in a profit zone. Now, no one wants to operate here where you're losing money all the time. You still got to do something, right? So they say loss, but continue operating in a short run. So like if you know you're going to lose money in a season, you still have to plant. You have to go through all that labor because you will lose less money. If before the season you say, oh my God, this is horrible. I don't think I'm going to be able to make any money. Why even plant? Okay. So those are the 3 zones. You want to pay attention to that. So entry is when a new firm enters the industry in response to increased profits. If everybody says, oh my God, people are making so much money planting this crop, I'm going to start planting that crop too. And then eventually so many people enter it that some people are maybe not as good at farmers as others, or maybe in a marginal area where the climate and soil conditions are not conducive to that particular crop, and they're not making the money they want. They eventually exit that industry and maybe enter another one or sell their land altogether. So long-run equilibrium are where all firms earn 0 economic profits, producing the output level where price equals marginal revenue equals marginal cost, and price equals average cost. When price equals average cost, and that's the break-even point. So really, they could have said price equals, which is marginal revenue, equals marginal cost, equals minimum average cost. Remember the magic here. The marginal cost curve intersects the average variable cost curve and the average cost curve at their minimums. That really is kind of magical. So, long run adjustment and industry types. So, if we look at the constant cost industry, as demand increases, the cost of production of the firm stays the same. Increasing cost industry, as the demand increases, the cost of production of the firm increases, and decreasing cost industry, as demand increases, the cost of production for the firm decreases. And this really has to do with the shape of these curves. So here's how they define that. If you have constant cost, remember when we drew two supply curves, two demand curves, and we showed demand increasing and supply increasing, and we said it really depends on the slope. Whenever we do this, if both of them increase, we know that the quantities are going to increase, and we had a question mark on the price. Well, in this case, we said sometimes it's going to be the same. That would be a constant cost curve. And then if it's this shape where the quantity increases and the price increases, and you know that, and you can tell, you know the exact supply curves, you know the exact demand curves. This would be, the long range supply curve would be increasing. And then on the other case, maybe the industry is very efficient, and you'll see that the long-term supply curve is actually decreasing, so that would be a decreasing cost. So this kind of closes the gap on that last discussion. So what was the case? Constant cost industry, increasing cost industry, decreasing cost industry. And here's the three examples. Now, you're probably looking at this and going, all these graphs, oh my God, I don't get it. I don't understand it. You have to go through this. You have to read the chapter on this, or else you will get lost. So, in A, increase in supply, demand increased and supply met it. Notice that the supply curve increases is equal to the demand increase. The result is the equilibrium price stays the same as the quantity sold increases. The equilibrium price stays the same. In an increasing cost industry, the equilibrium price increases with quantity. It might not be at the same rate. It's the slope of the long-range supply curve. Sellers easily increase supply in response to demand. Here, maybe new technology or economies of scale cause large increase in supply, so the equilibrium price decreases. I think this is what happens like with big screen TVs over time. The demand increased, the supply increased, technologies for making it increased, and increased at such a rapid rate that the price of those things came down. So efficiency in a perfectly competitive market. So when profit maximizing firms in perfectly competitive markets combine with utility maximizing consumers, the resulting quantities of outputs of goods determine both productive and allocative efficiency. That means you're producing without waste so that the choice is on the production possibilities frontier. In the long run, in a perfectly competitive market, the price is in the market is equal to the minimum long-run average cost curve. In other words, firms produce and sell goods at the lowest possible cost. I think that's kind of what happens. We might be seeing it now in this COVID era. in a sense. I think that depending on people's buying habits, have abruptly changed. And for commodities, some of these commodities that are perfectly competitive, like let's say maybe even gasoline, all of a sudden gasoline is like $1.80 a gallon because no one's buying gas because they're not driving as much because everybody's staying home and doing microeconomics. Allocative efficiency, again, means that the point on the production possibility frontier is the one that's socially preferred. In a perfectly competitive market, that's where the price, which is marginal revenue, equals marginal cost of production. That way you're not wasting anything. You're making exactly the amount that the market is demanding at the price the market is demanding. When perfectly, now does this happen all the time? No, it doesn't. The products go to waste. Things rot in the field. The government pays people to grow more of some crops, and or pays them not to grow any of that crop at all. When perfectly competitive firms follow the rule that profits are maximized by producing where price, which is marginal revenue, equals marginal cost, they're ensuring that the social benefits they receive from producing the good are in line with the social cost of production. Now, when we compare perfect competition to real world markets, it's a hypothetical benchmark, even though in agriculture, especially when there are lots and lots of farmers, it kind of applies. There's many issues that are assumed away. Remember when we talked about models earlier? And this is kind of a model. The model, if we talk about pollution, inventions of new technologies, poverty, like pollution will do what? Diminish the effect of crops and the desirability of them. Inventions of some new technology, you see that some European countries, you can read about it and Google it, are creating giant factories, large structures that are basically large hydroponic farms for growing produce in the middle of a city. And that can reduce the cost. Poverty. If you have too many poor people, some people are unable to pay for basic necessities. Government programs, like we said, the government decides they want to subsidize wheat. They want to make sure that we're the largest wheat producer in the world, for example. I'm not sure that's the case, and therefore pays farmers, put in a price floor. And so no matter what the market does, the government makes up the difference so that you're going to have always a surplus of wheat. And then you can sell it at lower prices, but the government then pays the farmers. For some reason, they want to do that. On the other hand, maybe we don't want, it's a profitable crop that we don't want farmers growing, and the government will pay them not to grow it. That's kind of cool. I like to have a farm where, hey, listen, I'm going to grow corn, or I'm going to grow this, that, or the other thing. And the government says, no, we have too many people making it. Here, we're going to pay you not to do it. Oh, thanks. Can I grow other stuff there? Sure. And then I'll plant other things there and hopefully make even more money. Discrimination in labor markets, buyers and sellers with imperfect and unclear information, which people always have. So remember that this perfect competition is a benchmark. And that's it for this lecture. I want to go back and remind you of 3 slides to really look at. You want to kind of understand this one. This would be like tier 2 understanding. You kind of want to understand that. You want to understand this slide for sure. And then you want to understand this slide. This slide is critical. And this slide. This is pretty busy. Notice that the marginal revenue is always flat. It's always a price. You have your marginal cost You have your average cost, you have your variable cost. The marginal cost intersects the average cost curve and the average variable cost curve at their minimums. The average variable cost curve is always less than the average cost curve, the difference between being the average fixed cost. These two curves, the average cost and average variable cost, converge at some point. They look like they get closer and closer together, but never do, as the quantity increases, because my average fixed cost is absorbed by a higher level of production. Okay? Thank you very much for listening, and we're off to chapter 9 next. Thank you.